Okay, I realized I actually gave you the wrong answer on one of the problems. Number 7. So
Okay.
I would like to cover this concept because I think I can clarify this concept quite easily for you by talking about the function e to the x.
Yeah.
If f of x equals e to the x, that's the graph of e to the x. What does it mean to say minus f of x? What would that function be?
It would be negative f of e to the x.
Well, negative e to the x. In other words, if f of x equals e to the x, then we just need to put a negative sign in front of it.
Okay.
And what is that? What's the negative indicate here? A reflection about which axis?
The x.
Okay, so that curve would look like that. Okay, now let's talk about this. What does that become?
That would be e to the x, right? Because it's even.
Now you take whatever's in the parentheses and you plug it in for wherever you see x.
Oh, e to the negative x.
Okay, that's a big important concept. What kind of reflection is this?
Reflection over the y.
Okay, so I'm going to take the original curve and reflect it over the y. Okay, so those are your two reflections. Now let's talk about the two vertical and the two horizontal reflections. If I say c times f of x, what would that be?
Vertical stretch or shrink.
Well, it would be, in this case, c times e to the x, right?
Yeah.
And you're right. An example of that would be 2e to the x. Let's draw a picture of that. We're going to work off the parent curve. It's going to make it steeper, like that. Okay? Let's take the other vertical measurement that can happen. F of x plus c. When I say c, I mean some number, a constant. Okay? What would this look like with this function?
E to the x plus c.
And an example of that might be e to the x plus 1. Well, what is this?
It like moves it up or down, so that would be moved up 1.
Vertical shift.
Yes.
So it's this curve, exactly the same shape, only moved up by c amount. Okay, so that's the only thing that can happen to it vertically, is we can either vertically stretch it or squeeze it, or we can vertically shift it up or down. Okay, there's only two other things that you can do, and that's horizontal stuff. Well, horizontal stuff, let's look at the easy one. What does that become?
That would be e to the x. Yeah, e to the x minus c, but the c's up in the x.
Exactly. We're going to take whatever's in the parentheses and we're going to substitute it for x. So what does this become? What kind of action, what kind of translation is this?
That's going to move to the right.
By c amount. In other words, if I had e to the x minus 1, then it would take my original curve and move this point that we know 1 over. Doesn't look greatly different, but it's a little different. And finally, there's only one last thing you can do. And what's this look like?
That looks like e to the cx.
An example of that would be e to the 2x. Okay? And this acts as a horizontal what? Stretch or squeeze factor?
Wouldn't it be a shrink
Yes.
if you take the opposite?
Yes, and that's where I made my mistake on problem 7. You're right.
Okay.
In other words, if we have this situation here and c is greater than 1, it's a stretch. It's a vertical stretch. If c is between 0 and 1, it's a shrink. But
Okay.
if we have this situation here, very similar, only the c is inside the parentheses, and c is greater than 1, it's a horizontal shrink. If c is less than 1, between 0 and 1, it's a horizontal expansion, a stretch. Okay? So if you can figure this out with the e to the x function, the e to the x function is a great function to use because each one of these looks different. Every one of them.
Right.
Every one of them looks different. Where if I use x squared, then they don't all look different. So it's real important to get this conceptually. Okay, now let's just take a quick look. I don't want to spend the whole session on it. At this problem right here. They wanted to know that there is some function, we don't know what it is, but if it has this point on it, what is the corresponding point when you do this kind of translation? And I think what I told you before was that 4 minus 11 was the correct answer.
Yeah.
But notice this 2x, that's inside the parentheses. What does that 2 do?
The 2 would shrink it by 1/2.
Ah, so instead of being 2, it'll be 1.
Yeah, so it's a.
4, yes. And then the 3 multiplies the y coordinate. So we have 3 times minus 3, which is minus 9. The minus 2 affects the y coordinate, moves it down further by 2, so we have minus 11. So this point becomes this. And all you have to do is know what each of these 6 things are to do any of these functions. In other words, knowing these 6 things on the left. And this is also a great illustration as to why f of x is better notation than y. If I use y here, well, I could still say minus y there, but I couldn't say y of minus x. I could say c times y, and I could say y plus c, but I couldn't say y of x minus c. So f of x is much more robust. It allows you to talk about each of the 6 translations that can be made. Now, the secret, a lot of times, is they give you the translated function, and you have to figure out what's going on. In other words, if I tell you that y equals e to the minus 2x, well, the minus sign is a reflection about the y-axis, because it's that. And the 2 is a horizontal compression because it's this.
Okay.
All right. Now, you sent me another paper today. You want to go over that? Or
Yeah, because I did everything else in the review packet, and we took the calculator portion of the test today. So tomorrow's the non-calculator, and it's going to be most of what's on that page.
okay, let's have a look at it.
I drew on it a little.
All right. I presume what we're doing is matching up these functions with one of the graphs.
Yep.
Okay? 28. What function is that?
28.
What's the parent function?
X squared.
Okay. What's being done to it?
It's being...
F of x is equal to x squared. Then what is x plus 1 squared plus minus 4? What two things are being done?
It's being shifted 1 to the left,
Okay.
and it's being moved down 4.
Okay. And what kind of look is it? It's a parabola, right?
Yeah.
So what, and it's a parabola that opens up or down?
Up.
Okay. So where do we have a parabola that opens up that's shifted left to the 1 and down 4?
J.
Okay, cool. All right. Let's look at M. What's the parent function?
X squared again.
What's the consequences of this negative sign?
Reflecting over the x-axis, so it'd be an upside-down parabola.
Okay, what's the consequences of that negative 3?
3 to the left.
3 to the right.
Oh yeah, they're right, sorry, because it's negative.
Right. In other words, this was 1 to the left. This has to be the other direction, 3 to the right. And what's the consequences of the minus 2?
Moves it down 2.
All right, so we're looking for an upside-down parabola that's 3 units to the right and 2 units down. We see anything like that?
Yeah, M. Oh, no, that's the left. So it would be B.
Okay. B is 3 units to the right, 2 units down. H. What's being done to this parabola? Oh, excuse me. I see what I'm doing here. Do you need me to go through each one of these or not? I just realized you answered all of them already.
Yeah, I wrote down because she gave us the answer sheet so we could like make sure we knew what we were doing, so I copied them down.
But it's still worth going through.
Actually,
Okay, yeah, let's go through each one of them then. So 30.
47. It's like I wrote 47, so sorry.
Okay. What are we doing on 30?
It's a x squared, so it reflects over the x-axis. It's going 1 to the left and 4 up.
Okay, what parabola? I don't see anything. We see anything yet?
1 to the left. Up 4. Yeah, H.
Okay. 31. What's being done to that?
It's going left 3, reflecting over the x-axis, and down 2.
Always do your reflections first. It matters.
Okay.
Depending on what else is being done to it, if you do the reflection second or third, it changes where the graph is. So just make it a habit of doing all your reflections as your first 2 steps. So it's an upside down parabola, 3 units to the left, 2 units down.
Okay.
Let's see. Here's an upside down.
Looks like
Yep. Okay.
I think I understand how to do the ones, like, understand how to do the x squared ones and the absolute value ones. It's like, I don't understand. It's harder for me when the lines all, like, look alike.
Okay.
So, like, the ones that are, like,
see,
have exponents in them are, like...
Let's do at least one of each. In other words, we just did 4 parabolas. And now I see that there are 3 square root functions. And then there's some absolute values let's look at. But let's make sure that in the next 15 minutes we do one of each type of these functions. Okay? So let's look at 32. I'm going to draw the parent function. What's the parent function on 32?
X squared.
Y equals
I mean, curve of x, sorry.
X, okay, and that looks like it starts from the origin because x has to be positive, y has to also be positive, so that's what it looks like. Okay? So what's being done to this?
It's being reflected over the x-axis and moved up to.
Not up to.
Oh yeah, to the left too.
Plus 2 is inside the function. In other words, if I was going to write this in f of x notation, it would be f of x plus 2.
Okay.
Well, it'd actually be negative f of x plus 2. But that's different than f of x plus 2, right? This is horizontal, this is vertical. So we got horizontal 2 units to the left and a reflection. Well, we're going to do our reflection first. Move it 2 units to the left. That's what we're looking for. And let's dispense with trying to find it. We'll speed things up. You know what I'm saying?
Okay.
Until we get the one that you really have troubles with.
Okay.
Okay? I don't see anything else here that
No, those don't look particularly like I'd struggle a lot.
well, we do have a couple of strange things happening here. Let's just talk about 33. Y equals the square root of 4 minus 2x plus 1. Well, what that really is the square root of minus 2x plus 4 inside the radical sign plus 1. So what's going on here?
It's being horizontally shrunk by 1/2 and reflected over the y-axis.
Okay.
And left 4 and down and up 1.
Okay. Almost correct. I really have to rewrite this, and this is the hardest part about translations, as minus, in parentheses, 2x minus 4. That would tell me that I am reflecting over the y-axis. Okay? But after I reflect over the y-axis, I have to move it to the right by 4, not to the left.
Okay.
And it's all because of the fact that I want to put minus in front of everything else that is in that function. You see why this is the same as this?
Yeah.
Minus 2x plus 4. This is the same as this. The difference is that when I write it like that, I now have clear negative sign in front of everything that's inside the radical. So I clearly have a reflection over the y-axis. And then if I examine this, you're correct. It's a shrink by a factor of 2, but it's a movement of 4 to the right after I've reflected. So this isn't that easy. This is actually a little tough. And then, of course, the plus 1 is just a vertical shift up 1.
Okay.
All right, let's go to a different function. Let's go to the absolute value function. What's the parent function?
It's y equals the absolute value of x.
Which, you know that absolute value functions always have a v in them.
Mm-hmm.
Always have a cusp or a corner like that. So, what do we got going on here?
It's going to be reflected over the x-axis, so it'll be going upside down.
Okay.
It's vertically, horizontally shrunk by 2.
Okay.
Right 1.
Okay.
and up 3.
How are you getting an F in this class?
Yeah. I get stuff right now. It was at the beginning of the time that I didn't understand.
Never had a student who's getting an F that knows as much as you know.
Really?
You know this stuff.
I know this stuff, yes. The stuff that we've been working on while I've been working with you,
Okay.
and
All right.
I get it, but yeah, stuff at the beginning of the year I did
I
not.
get it. All right. All right. So let's keep just doing this then. I don't know what else we can do here. That's no difference, right? That's the same parent function, same reflection over the x-axis, move 2 to the right and up by 3.
Yeah. These ones I'm pretty bad at.
Well, they add these brackets, but what's the net effect of that bracket? Is that not the function on 37?
Yeah, it is.
I mean, if I remove the bracket, this is what I have. What's the parent function?
Y is the greatest integer of x. I don't know how to say that.
Is that what this means?
Yeah.
Okay. So it's not a parentheses.
No.
It's greatest integer function.
C.
These are definitely tougher to do in terms of reflections. So the parent function is y equals greatest integer of x, which looks like this. Okay?
Yep.
In other words, the greatest integer of 2.4 is 2. Okay. So let's see if we can figure this out based on these translations here. So we got this 1/2. What's the consequence of that?
That horizontally stretches.
By a factor of 2. Good.
Yep.
Consequence of this?
Moves it to the left.
By 2.
Yeah.
The consequences of that?
Down 1.
All right. So the question is, let's see if we can draw it and if it makes sense. And with this particular one, you really need to make sure that it makes sense. Okay, so I'm going to expand it by 2. So if it was just 1/2 x, this first line would go from 0 to 2.
Okay.
But it's also 2 units to the left and down by 1. So if I go 2 units to the left and down by 1, then our curve, the first leg of our curve, should look like that, where it's at -1. Now, the true test is, let's pick a point between 0 and -2 and see if this curve matches it. Pick a number between 0 and -2.
-1.
Okay, so we now have well, 1/2 of -1 is -1/2 plus 2. So now we have the greatest integer of 1.5 minus 1. What's the greatest integer of 1.5?
1.
Minus 1 is what?
-1 Lose it down one. What were you asking? I forget.
Well, what is the answer to this?
Oh, that would be 0.
Yeah. So this curve doesn't match it. So we're doing something wrong here. In other words, our curve needs to be on this up here. In other words, this is telling us that when x is minus 1, y needs to be 0. And right now we've got y at minus 1. So we've done something wrong. And what could it be? Well, my guess is we need to factor this 1/2 out so that we turn this into, and that's why these are so hard, these greatest integer functions.
Right.
All right. See what I did?
Yeah.
Okay. Now we have a shift of only 1 to the left.
Okay.
We have a horizontal expansion by a factor of 2.
Okay.
And we have a shift down of 1.
Okay.
Still doesn't put it right.
I know. And if you look at the graphs that were given, it says that for that one, that n is the correct answer, and it matches what you're saying, that it should be on the first line should be on the
Right.
x.
Whereas
Yeah.
when x is minus 1, y should be 0.
Yeah.
And that is the proof of the pudding on these. Now, I'm going to have to study this greatest integer a little bit more here. Unfortunately, we're out of time. But, in other words, we need to figure out what we have to do here in order to end up with n. Clearly, I thought I was following the right path, but I wasn't. We ended up with the wrong graph that didn't match what we know had to be true.
Right.
So we need to figure out exactly what's going on here. In other words, is this f of 1/2 quantity x plus 2? I think it's really, if I try to write this as f of x, then it's really f of 1/2 the quantity x plus, now I get it. This was not correct here. This has to be 4. I made a math error. In other words, what we're looking at on 37 is f of 1/2 times the quantity x plus 4.
Okay.
Because f of x plus 4 would be this. But when I put the 1/2 in front of it, I have to put the 1/2 in front of all of it. And that actually becomes what they have given us, is 1/2 x plus 2. So
Okay.
plus 4 should be a horizontal move to the left of 4. Aha, and that's going to solve our problem. Notice that after we move it to the left by 4 and we stretch it by 2,
so at -1.
Move it down by 1, this one of these two here is going to end up right there. And that's where we want it.
That makes sense.
Yeah, and that's what you have to do. In other words, you have to take what you're given and try to put it into something that you can define as f of some kind of x. In other words, if you have the horizontal stretch factor and the horizontal slide factor, you need a parenthesis around the x plus 4 here. And in order for me to put a parenthesis around it, I got to factor out the 1/2, which leaves x plus 4, not x plus 1. I made a math error the first time. And that's why my graph didn't end up correct. But if I use this, now I got to move every one of these 4 units to the left, and then I'm going to move them down 1. One of these is going to end up right there, I guarantee it, so that we have the correct graph.
Okay.
All right.
That makes sense.
Yeah. Well, unfortunately, I have another session I got to run to, but good luck to you. I hope I've been helpful here.
Yeah, you have. Thank you so much.
The real key here is knowing these 6 things on the left.
Yeah, I took a picture of that when you were doing it. So
this is absolutely vital to know what each of these things does here. And then being able to take any function and figure out what is being done to it. In other words, is that f of minus x? Is it minus f of x? Is it some constant times f of x? What is it? And once you can do that, then you'll know what's going on to each of these. And
yeah, that makes
for
sense.
sure the greatest integer function is the toughest. The sine and cosines are actually quite easy, and so are these hyperbolic functions, and so are the log functions. The only ones that are really truly difficult are these greatest integer functions. Those are beasts when it comes to figuring out the translations that have been done.
Oh, yeah.
All right. The key is once you get done, and once you've done the translation, plug in a number and make sure you're on the right spot. And that way you'll know if you've done it right or wrong.
Okay.
All right?
All right. Thank you so much.
I will talk to you next Monday at 7, correct?
Yep. Sounds like a plan.
Okay, Aspen. Have a good week. Bye-bye.
You